Okay, so here we have got a problem on combination of resistors. A student experiments with two resistors of resistance 8 ohm and 6 ohm. He connects them in a circuit to a 12-volt battery as shown in the diagram. So if you look at the diagram here, it is a series circuit. There is only one single path, one single loop. That means 8 and 6 ohm are in series. It's asking us what is the current through the circuit. So to find the current through the circuit, because it's a series circuit, we know that the total current will be the same as the current for each resistor. So we can just use the formula for total current, which is V for the battery, potential difference of the battery, over R total. Now to calculate R total, because they are in series, R total will be equal to R1 plus R2, which is 8 plus 6, that gives us 14 ohms. And the voltage or the potential difference of the battery is 12 divided by 14. Let's just get that value. 12 over 14 gives us 0.857, which I'm going to round off, 0.86 ampere. Don't forget the unit, 0.86 ampere. Then it's asking us what is the potential difference across 8 ohm resistor. That means we want to find what's the potential difference across 8 ohm. But we know that the current will remain the same. So the current, which was the total current, is the same current which is flowing through each resistor. So the current I is 0.86 ampere. We want to find the potential difference, and we know that the formula for potential difference by Ohm's law is given as I times R. So we'll write 0.86 times, because we want the potential difference across 8 ohm, so R we will take it as 8, and we can multiply 0.86 times 8, that will come out as 6.88. So we can round that off as 6.9. We'll put the unit for potential difference, that is volts. Okay, now similar question is there, but here the resistors are connected in parallel. So it's the same two resistor, 8 ohm and 6 ohm, but they are connected in parallel. How do we know that it's connected in parallel? Because we know that the current from the battery, when it reaches this junction, it's going to split into two parts. So 8 ohm and 6 ohm, they are getting their own currents. That means the total current is going to split at this junction, and that means that 8 ohm and 6 ohm, they are connected in parallel. So first thing is asking you what is the equivalent resistance. So to find the equivalent resistance, I'm going to solve the first part here. We are going to use the formula 1 over R total equal 1 over R1 plus 1 over R2, which is 1 over 8 plus 1 over 6. Let's just calculate that. 1 over 8, I'm using my calculator here, 1 over 6. On the calculator, that gives me the answer as 7 over 24, which I can get in decimal, which will come out as 0.2916, so 0.292. But that's the value for 1 over R total. So let's just write down that 1 over R total we got as 0.292. In order to get R total, we need to flip the answer. That's important step. We need to flip, so that will come out as 1 over 0.292. And that answer comes out as, let me just check, which is 24 over 7, which is 3.428, which we can write as 3.43 ohms. Okay, so what's the most important part in a parallel circuit while calculating equivalent resistance? is to remember to flip the answer after using the formula. So almost everyone can stop, like we can make a mistake of stopping at this point, but we need to remember that this is not our total, this is 1 over our total. So we need to flip the answer to get the value for our total, which will be 3.43 ohms in this case. Next is asking you what is the current drawn from the battery. So what's the word used? Battery. That means we are interested in total current. So if you want to find the total current, so for the second part, I total. How do I know I need to find total? Because it's using the word battery. I total will be the voltage of the battery over R total. So that's 12 over 3.43. So 12 divided by 3.43 gives me the answer as 3.498, which I can approximate, and I can write as 3.5 amperes. So that's how we can find the I total for this circuit.